If you assume that I know absolutely nothing about what you were doing, but you wanted to explain your ideal customer profile, what are you selling to whom exactly in layperson's terms?
Yeah, I think the blanket statement is like, okay, what is the motivation? The motivation is we want the world to have more chips, right? And so there's kind of two ways we go about it.
Why do you want the world to have more chips?
One, the disaggregation. One, the demand is just insane right now. And I think the biggest like motivation of like why we started the company was like, I want a humanoid in my house, right? Like, why is there not a humanoid, like filming and holding the camera and like moving it around, right? Like, obviously, like, there's just so much in the world that is like unexplored, and we just can't explore it because we don't have the
So
compute. We
your
don't have the
worldview is more chips leads to more agents of improving society.
exactly. Like, I'm not excited in like more chips because now we can sell them and make a lot of money. For us, the motivation is like chips ultimately enable this world that we want to live in, right? It is going to enable the data centers in space. It's going to enable like flight to Mars, and like new chips are going to have to be built to like run rovers and like Mars and stuff. We need humanoids. We need cars. There's gonna be like everyone's gonna have like these wearables. Like there should be glasses on our face right now that record everything and like can tell us about our day. Like all of these things are imminent. Like you hear people working about them, you hear the buzz, but they're not there yet, right? Like they're nowhere near what they should be.
I mean, it sounds like you're basically standing in front of the biggest positive risk tidal wave of all. And it's kind of like a weaving problem now, figuring out how to deliver value to specific customers to get the flywheel going.
Exactly, yeah. And I think another good thing about us is, like if you kind of look at this motto of TSMC initially was not doing many great designs. They were doing small designs, one-offs, chips that maybe Intel didn't want to manufacture, right? And then all of a sudden they started doing more designs, they started getting better and better at it to a point where Apple was like, okay, I actually want to use TSMC to do the next iPhone, right? And for us, it's a very similar scaling trend where like,
That fracturing was very big,
yeah,
that they would use them for fab.
yeah,
And now TSMC, I mean, could be the biggest company in the world any day now.
exactly. And I think it's the exact same for us, or like in terms of like process wise, where you start working with people that are maybe resource constrained or need help, but over time you start to attract more and more interest where people want to jump on the train, right? And at some point you start getting these bigger and bigger orders where now it's very feasible to see architect taking on a full chip program where it's like
Yeah.
we hand architect a PDF and they are giving us back the end die from the foundry and shipping it into a product.
Yeah, there's opportunity for more customization. There's opportunity for acceleration of timing, compression of pricing, all these kinds of things. Whereas the chip industry, when it first started, it feels like it was more of a monolith, just selling sort of, one thing at a time.
Yeah.
And now I think there's a huge opportunity for you guys. You're essentially wading in the waters of what has arguably emerged as the absolute biggest industry in the world. Everybody's talking about chips. A trio of the top 10, top five biggest companies in the entire world are directly focused on this. Take us on a tour of the history of your industry.
Over time we've sort of seen like the industry evolve and now there's obviously the kind of like famous Moore's law, right? That the size of the number of transistors on a chip is going to double every 2 years or like 1.8 years type of thing. And that is obviously that is now plateauing, but really the industry was like continually fueled by this motivation of like the more transistors we can pack on a chip, the better results we can get, the better experiences we can deliver to people, the more compute we can have. And obviously there were like, I would say the industry, to be honest, has not changed much since then. That has always been the driving goal. Obviously the way we've done things is different. There was kind of the birth of these like fabless companies. There's the birth of the fabs like TSMC. Then there was the age of synthesis where before what the designers would do is basically they'd have the circuit in their mind and they would roll out a piece of paper, like this massive like parchment paper on this like big table, and everyone would draw the transistors by hand that they would send to the fab, right? Kind of like just like drawing the building that they're trying to build. But then all of a sudden there's like this like synthesis revolution that's essentially saying that, okay, we could just take in some code and then automatically generate what humans used to draw these like pictures by hand, and so that was kind of this like second era. And then I think since then, like the tools have been getting better, the transistors have been getting better. Generally, the people are the same, right? It's these hardware engineers that know a lot about their discipline. And I think now we're at a generally more exciting time. And I think reason why it feels like the media is shifting is partially also to do with the slowing of Moore's law, is that the demand for compute and memory and just in general all sort of applications is at its peak, but Moore's law has kind of stalled in the sense that the transistor is getting so small that we can't really shrink it down anymore. So I think that's sort of what's leading to all this discussion nowadays. People are trying different things. You have new companies fighting with old companies, and the ground is not really certain who's going to win, purely because the laws that we were used to for 40 years have kind of now been flipped on their head, or now people have to think about new ways of designing. So I think that's a generally exciting moment. I think that's why there's so much buzz, and obviously fueled by AI, the demand is greater than ever. So it's kind of this moment where all these things are coming together, and I think the world is being forced to change.
Are we in the early days of demand for compute, or is it overstated and cost per unit of compute is going to plummet and there's too much hype now?
It's hard to say. I think the way I look at it, rather from a cost perspective, is more so like how, obviously AI is the biggest driver of all this compute, right? And obviously people believe in scaling laws, some people don't, but generally I think what people believe in is that AI is somewhat maybe underutilized or underappreciated by like a global economy, right? In the sense that the fraction of people that use the frontier models are actually very small. And then the fraction of people that maybe use the maybe around 10% of the world are like ChatGPT users and Gemini users and things like that, right? And then you have this whole other corner of the world that is waiting to be accelerated, but is actually not maybe feeling the impact. Maybe they don't have the exposure. Maybe they don't have the kind of network effect of being in Silicon Valley and everyone's talking about AI, right? And I think there's that side. There's also the side of really everything else we're like promised, right? Like AI is supposed to create this like sci-fi future where we want like robots and humanoids and we want self-driving cars. But if you just look out the road anywhere, it still feels very like nascent, right? Like the world is like just starting to get there. And so I think that is how at least I think about compute, or is compute undervalued or overvalued? I think whether or not, regardless of the price at which these GPUs are being sold at, which is obviously insane, there's definitely the demand, and there's definitely just so much to be done to make this AI like have it live up to the promise that people are saying it's going to have.
And when you think about the history of the industry and where we are in the secular boom in AI, what opportunity was left unattended for architect to pounce on?
I think the general, it was kind of these two factors that kind of came into play at the right time. Actually, maybe three. I think the first was that obviously we just generally started to see the kind of like disaggregation of chips, right? The general thought process before was we want one type of chip. And actually that was, CPUs back in the day. Everyone thought that CPUs were going to be the only thing. And this company NVIDIA called along and was like, okay, what if we made a chip just for graphics, right? And everyone was like, this is kind of silly. Like CPU could just do everything. But GPU in a way was a specialized form of the CPU.
So silly that NVIDIA is the biggest company in the world now.
Yeah. And so, that obviously that's a different type of specialization, but that was kind of like, at least what I point to, like a very clear example of like disaggregation. Like we took something, we split it up into what used to be CPU into now CPU, GPU. And then over time, that was kind of really it. You had a few things here and there, but that was what people knew. And then all of a sudden you had just this explosion of different things coming out. You had, Grok with their LPU, you had Google with TPU, chips were doing prefill and decode, and the model was being broken up across different parts of the data center. There were different chips doing different things. And it just felt like, you could very clearly see that the pattern was only going to continue, that there's no way that chips would start to consolidate, and they will only continue to like disaggregate more and more, right? And so that was kind of like the first tailwind. I think the second tailwind was, these chips are, obviously very difficult to design, right? It's what makes NVIDIA so valuable. It's what makes, TSMC is so valuable is that what they're doing ultimately is so difficult for someone to go out and say, I want to do this, right? Which is kind of counteracting the disaggregation play. It's like somebody on one side, we're saying we want more chips, we want different types of chips that do different things, new things. And on the other side, somebody's saying, this is really hard to do. It costs $1 billion with a 1,000-person engineering team, right? So that's where the clear problem is. And I think, but that problem has existed for a while. I think the kind of key moment that my co-founder and I felt was, with AI, you could kind of see a path of chip design being this very verifiable task. You could really see this path to where some system could be put together. Obviously, when we founded the company, it was not clear what the system would look like, but over time, we really have spent a lot of effort really finding a way where these AI models can do what humans maybe were not able to do or took too long to do. And I think these three things just all coming together at the right time, it just made sense to start the company. And it didn't make, obviously you have the context, but my plan was to go do my PhD, right? And so it just felt like a right moment where this, even in a year, the moment may feel stale. But when we started it, it was just like the perfect time where all these things were coming together. It was potentially non-obvious how these things would work. And at that point we decided let's go out and kind of just do this and, take it full time, I guess.
And you use the term a lot, designless semiconductor industry. What does that mean exactly, and how does that relate to the dynamics you just described?
Yeah, I think like generally, if you look at anything, let's forget about chips, right? If you look at anything, the more complex something is, the more essentially like help you get along the way. So initially, chips were obviously complex, but nowhere near the degree they were today. And so you had these kind of companies like Intel, right? They would own the fab, they would own the design, they would own the firmware, the architecture, they do basically everything, right? It was just like this monolithic company, which is why they were so successful, right? Is that they really controlled every part of the process. But at some point, it became really hard to be kind of masters at both designing the chip and fabricating it and, delivering it to the customer and all these things. So that's where kind of like, this fabless idea came up, where there was this company called TSMC, and TSMC is saying, okay, I'm going to handle the fab part, and all of these companies, I'm going to do this hard work for you, right? And you can now work on this harder task that is actually building the chip and designing it and doing all that. And so that's kind of where you see the birth of like NVIDIA, Broadcom, Apple, right? They can, because they sort of have freed up their like mental bandwidth, TSMC has essentially taken a weight off their shoulders. They can focus way, way more on their like core technology, which is their design, their architecture, what they're trying to actually achieve. And, that, following the fabs was kind of the kind of synthesis era, like I mentioned, right? Now you started having EDA tools rather than people drawing things out and typing things by hand. They would actually just put it into a tool. The tool would spit out some results that you would then send to the fab. And so over time, just like there have been these very clear points of chip design because, it is arguably one of the hardest disciplines in the world. There have been more and more help along the way to allow people to deliver these like amazing chips. And I think designless is really just a natural extension of that, where it's saying, we're seeing all this disaggregation. We're seeing people are trying to build more chips and buy more chips, and just demand is through the roof. We also see that these are very difficult to make. And so is there a future, the future we believe in is there a future where we can help companies that may be building new types of chips or maybe even not have a chip team, all of the above, people who ultimately are if their goal is silicon, how can an architect help them get there as quickly as possible? And that sort of is the designless vision, is we don't want you to have to worry about architecture and design and verification. You should just focus on your workload, your end application that you're trying to serve to the world, and we will handle the compute, we will handle what the chip should do, how efficient it should be, why it can be so efficient, and we will take it from there all the way to silicon and give them the chip back.
Yeah, it's a brilliant idea and a perfect name for the company, because just in the moment in history when demand has gone vertical for these things, the applications of them has widened a lot. Mm-hmm. And so I think for a lot of businesses that want customized solutions that you've described, being able to be sort of that architecture layer, if you will, compress time frames and deal with the fact that, I mean, at this point, if you don't have $1 billion, you can't really go to certain companies. And so I think this is a huge, solution for that segment of the market. How did you originally, sort of have the aha moment to focus on this with Adi, your co-founder?
Yeah, I think I guess it's sort of goes back to the story of how I met Adi. So initially, I was just I was interning at a few chip companies. So I spent some time at Apple. I was on their silicon team there, and then after Apple, I went to Tesla to work on AI5, which is the kind of like inference processor. And Tesla was a clear example of this, like another very clear example of like disaggregation, right? It's that we were we're building this car. It's going to the intent, the vision for this car is that it's going to be worldwide, right? It's not it's fully camera based. It can drive anywhere in the world. It should be self-driving anywhere we want. And because of that, if we really want that to be true, we need our own silicon. We cannot be affording to buy, priced per unit pieces off the shelf. We need to control the model. The power matters in the car. We can't be consuming the amount of energy that a massive GPU takes up. So there's all these different factors. And then, being on that team at Tesla, it really showed me like how difficult it was to do that, because obviously Tesla, they have put out this great chip. AI5 is an amazing chip, but it was probably not an easy road to get there, right? And Tesla at its core is not a chip company. They're a car company, right? A chip is essentially something that they need to build the best car in a way. And so from seeing it from that perspective, that's what sort of started getting me really excited about the kind of prospect of, if this is going to continue to happen in the future, if more and more companies will do, what Tesla's doing. I mean, you see Rivian doing it now, you see many other companies doing it now. But if more and more people are going to do this, it doesn't make sense for everyone to struggle the same way, right? It's the same way with the fab, right? If many people are going to make chips, why should everyone have to build their own fab? It just doesn't make sense. So I think that was the initial very clear moment where I was like, okay, I see the problem, I feel it, working with these Tesla engineers, I feel it. Now, what's the solution, right? Where can I look for the answer to this problem? And I think at that point, I actually never knew I wanted to start a company. So, I just came to Stanford, as you know, I was just a visiting researcher there. And it was really just spending my time, I just took like kind of a break off school, just really spending my time thinking about the problem, getting to talk to some really smart people and working with them, conducting kind of my own research as well. And at that point, I just, met Adi around the city. And, while I was in Silicon Valley, we just started researching together. I mean, he's a researcher at heart as well. Just started working out of the lab together. And then, as you know, that's where we kind of took our first Zoom call. And then I think since then it was just like, the best way to continue this research is to start a company, right? And I think that was the birth of Architect, was not really the feeling like, okay, we have to, what is a company or what is the interesting problem? It's more so like, it felt very natural. It's like we stumbled across this problem, we kind of fell in love with it, spent our time like with no real incentive. We just were doing it because we loved it. And then I think naturally the company just started to grow, and we started getting more momentum and more people excited about it. And, I guess that's where we are today.
It's extraordinary that by the ripe old age of 20, you had experience in, top research lab at Stanford, Apple, and Tesla, when you ultimately flipped the switch and wanted to start a company and are now well on your way. What wisdom did you take from your experiences at Apple and Tesla? What were the things that you observed that you wanted to emulate that make those companies great? And what did you observe that didn't feel stylistically consistent or were opportunities to do things a different way?
Yeah, I think I think the biggest thing I took away from at least like my big tech experience or even my research experience was that really like obviously, and it's not like a contrarian take, but like, the people really drive everything. And even though these big companies have a lot of, these teams are massive, it's really hard to pick out, who is really the top contributor versus who is like an average contributor. I think really like working, at least maybe on the Silicon team, it was different, but you could always point to some like maybe new feature, some new invention, some new crazy idea that someone would not have thought of. And it always points back to just these like people that just came up with these great ideas. And that's why the big companies are able to innovate so much, right? Is like they have the capital, they're also able to attract these great talents. The chip I worked on at Apple was, just few engineers. I mean, Tesla's also a very small team, right? And so it's kind of interesting to see how this like really core group of like 10, 20 people can deliver this experience that like truly a billion people are going to interact with, right? I think that was really an exciting prospect, and just like getting to learn like what makes a good engineer, what makes one engineer better than the other. Like I think that's a very important, skill that we look for. And I think also what may also slow these companies down is there's almost very little risk to, or the risk to reward of maybe innovation or changing something is not really there. And so for them, it's more so like I've done analysis of the market, I understand what the product needs to be, and when they're going out and handing it to the technical team already has. There's a completely different team of like the business side that has basically done all the analysis, and now it's the job of the technical team to just get that out the door, right? They're given the start date, the end date, the end deliverable, and it's say, okay, go build this for me, right? And obviously at a startup, it's not like that, right? The market can change tomorrow. You don't even have enough engineers to do what you want to do, but you still have to find a way to do it. The analysis you make is off of very sparse information. These big companies have analysts that go out and find what's going on. They have spies in other companies that pick out details and put them in a Notion doc of, details. So now it's like, as a startup, you just have this like very few maybe bullet points, and you need to kind of chart the path. And in that sense, I think one is obviously it's harder, but the benefit is that you can take more risk, you can try new things that may not be explored. And I think that's the biggest leverage, like when we think about the company, is what are the kind of radical ideas that the big companies are not trying? What is an idea that maybe was overlooked 10 years ago that maybe now has some merit in this different context and this different landscape? Like a lot of these ideas are, a lot of great ideas have actually been explored earlier. It's just maybe not at the right time, or it needs a little rephrasing or rethinking. But I think just being able to like look at that, I think is a big skill that maybe I think a big company doesn't practice.
And when did you get excited about engineering, and was that an early childhood thing?
I think so. I think I can't point to a specific moment. What I would say is that generally I started to enjoy like the freedom. I think that is something that is hard to get in other disciplines.
The freedom to build and express? Or?
It's like the freedom to do something non-obvious or do something in a different way. Mm-hmm. I feel like even with traditional software, there's a lot of complexity in software. All of my time now is spent writing software, but what makes software, what made software, at least to me, less exciting as a kid was it's very, sometimes it can feel very like possibly repetitive. It could feel like there's not much like, if I, let's say, build website A and then I go build website B, of course there'll be many different things, but I know that I'll kind of like need a database, and I know I'll kind of need a front end and a back end. That's one example. But I think like engineering is like, the space is so open. Like you have to think about whether or not you use a specific type of bolt, because if the design gets sheared this way, this bolt is better at snapping, or this bolt is actually bendier. Like there's just so many like details where software, they just get abstracted away, right? And that detail is true for like mechanical engineering. It's true for electrical engineering. You have to think about like the current and the noise and the electrical fields. It's true for chips. You have to think about every transistor, the power, the manufacturing, the placement and the routing. So I think like generally was always drawn to these like fields that just require so much attention. It just felt like the most engaging. I think it's a good way to like kind of get lost in our problem. Whereas like I really did not like fields where it's like things were abstracted away and like you kind of had a rule book of like, yeah, let's do this, let's do that, or like a preset pattern. I think engineering just gives you that freedom to do things that maybe are wrong, but maybe they just turn out to be right later on.
And one insane thing about you is that you literally skipped high school. You didn't go to high school. You went straight from before high school to college. You sometimes hear about people graduating college early or graduating high school early, but you don't usually hear about somebody skipping high school. So what age did you start college, and what's the story of how you literally skipped high school?
Yeah, so I started college at 14. I went to University of British Columbia, so just like my hometown.
Was your voice high or low?
Way higher, like
It was way high.
way higher, like actually like very
Squeaky.
squeaky voice, to the point where I stayed very quiet in my first year, like just like
Because you were worried you would sound too squeaky like a mouse, or?
I mean it's just like very clear. It's like okay, this person's like definitely a kid. Like you can like
But
right.
you knew the answers in your head, or no?
I mean sometimes I didn't know the answers, but yeah, I think
Okay.
yeah, it was just like I stayed very quiet in my first year. I think like what you know it comes back to the same point, right? It's like as a kid, it's very difficult to kind of do these like deep engineering things, right? It's very hard to like go to like find like where's the lab where you're gonna cut the metal and you know solder the pieces together, or, you know, all these different things. Like you just don't have access to that. And so for me, it wasn't like, oh, I want to skip high school because it's easy. It's just like I could wait 5 years and just like go through the curriculum and that's fine, and then go to university. Or like, what is kind of the quickest path for me to do what I actually want to do, which is like build complex things, like build different systems, play around, like have fun. High school again is like one of those things where it's like you kind of just have to do it, right? Like you just grade 8, grade 9, grade 10.
Did you raise your hand and say, I want to skip high school? Or did somebody tap you on the shoulder and say, you're super gifted, you should do this?
I think, I mean, it wasn't initially clear to me that I was able to do it. I think people around me definitely said like, hey, this option is available. Obviously, not every school is open to it. I think one good thing about University of British Columbia is they had this program, and they would essentially take 20 students a year, and those students would all kind of skip high school together. So there's this like transitionary period where you would kind of go from just elementary, you would all work together in like classwork and schoolwork with 20 other people or 19 other people, and then you would actually admit to university, and that was kind of, you know, I think that's also where I met like a lot of people that kind of felt the same way about.
Have you stayed in touch with anybody from your 20-person cohort? And then overall, looking back now, seeing what they're doing, do you think that it accelerated their success, or it was too much too soon?
It depends. Like some of my, I mean, I'm definitely friends with a lot of them, and some people feel it very differently than others. I think it's. I mean, we always ask the question like, would you send your kids to this program? I think the answer, strangely for us, is like possibly like a ubiquitous no. Just because you know, while it is like, while we really did appreciate the opportunity, it's also like, you know, it also takes away, it also potentially could take away a part of your life that like maybe you hadn't explored or you hadn't tried. So obviously we don't regret the decision. We're super like, you know, I'm super close with them, and they're all doing like different things. Like I feel like I'm maybe one of like the only like engineering ones. A lot of them are like super into software. A lot of them are super into AI. A lot of them are super into art. I think one of my best friends just graduated, and he just like plays guitar all day. And as a like side job, he just works on like some websites for this like software company. But he just plays the guitar all day. He like goes on tour, and I think that's pretty cool. So I think it's like, yeah. I mean, like it's not that this program is like forced to create like academic geniuses that are like, you know, just coding all day. I think it's just like it's an accelerated path to doing what you want to do. But also sometimes like there are other people who I know that maybe wanted more time to figure out what they want to do, right? Because in university you have to pick a major, you have to decide what courses you want to take, and sometimes more time is helpful. So I think, you know, while I don't regret it, I think some people would appreciate the more time.
One of the things I have thought about with respect to you is, by doing this, you of course didn't get your summer where you know, swing in a tire swing from a tree into the river, just frolicking basically.
Yeah.
But there is some like childish playfulness almost in building and like erecting things basically.
Yeah.
And you're bringing that to what you're doing now. And so in a way, you're still getting to be playful like a child and have a huge sense of wonder. It's just really sort of, you know, front loaded for you.
Yeah, for sure. I think like one thing is, and I think that's a good point. I never really thought about it like that, but definitely, as you know, like the company was never started out of need to like start a company. It was like, I just want to do this, or you know, my co-founder and I were just like, we just want to do this. It's fun, and like we're young and we just like enjoy solving the problem. and like that's really it, right? It's that's where like the core love from it comes, and like I think it's also why we've been able to have a lot of fun, make a lot of progress, and like work with some great people, just because it's for us it's not really like a job, or like it doesn't feel like a job, but.
And were you a self-explorer growing up, or did you get some tutelage from, your parents or your teachers? Was anybody sort of engineering pilled in the house, if you will?
Yeah, well, my entire family is like descendants of engineers. So my mom was a civil engineer, and she helped kind of manage these like building projects in BC, like these like sky rises. And then my dad was a hardware engineer, and he basically has been at Broadcom for like 25 years. And I think definitely I picked a lot of it up from my dad. One story that I kind of remember is I was, he initially kind of like bought this like kit of like little electronic pieces for my sister, who's 4 years older. So at the time, I think I was maybe like 8 or something like that, and my sister was 12. And my sister, she was not really a big fan. She's studying a doctor. She's studying to become a doctor now. So totally different field, but she hated it, right? She didn't like these like little toys and like little trinkets of like put this wire in this pin at the breadboard and connect these things. And so, but my dad was always like trying to get her to do it. So at some point she kind of just offloaded it to me, and she was like, "Hey, can you do this for me so I can tell him that I did it?" And so I just started doing it because she told me to do it. And then at some point I started really liking it, and then I just started taking it up on my own. And then I think my dad also laid off my sister a little, because he was like, okay, as long as I can like, instill what I like to do onto one of my kids,
Right.
then I'm happy. I don't mind. So I think that was, yeah, I definitely wasn't like forced, just like natural, but I just ended up liking it. And obviously my dad has been a hardware engineer for like forever. So I guess he likes it too, to some degree.
What's his take on what you're doing at Architect? You mentioned he's been at Broadcom for a quarter of a century now.
Yeah.
As a hardware engineer. And Broadcom is no small company. I think it's larger than $2 trillion market cap, something like that.
Yeah.
So I'd love to hear, whether he's approving of what you're doing or not. And if he's disapproving, why you persisted.
Yeah, I mean, obviously he knows that the problem is there. There's no question about that. Initially, he was a little like reliant to like, okay, you should kind of finish your degree and go back to school, because the initial plan was like, the reason why I was at Stanford was I was doing this visiting researcher internship, and I actually wanted to get a PhD thereafter.
Right.
And so like we were kind of set on that, or like I kind of told him about it, and he was like, obviously he was excited about like, oh, my son's getting a PhD, right? It's like obviously that's nice. But then yeah, I kind of
Sounds good around the holidays.
yeah, for the Facebook posts,
Yeah.
right? But at some point he was like, it was just we did the entire fundraise, and then I just called him one day, and I was like, yeah, I actually want to do something else. We've raised this like a small round. I just want to spend some time working on it. And he was like, what is this? Like, why would anyone ever give you money? That was the first question. And I was like, I asked myself that question too. But market is.
And is that because of your age or lack of PhD or lack of experience working for a prolonged period of time at one of the top companies there?
Yeah, I mean, like the way he's like, I mean, for 25 years, right? It's like you do good work, you then learn more, then you become then you rank up, you become L1, L2, L9, whatever, principal engineer. And so then, and you only become that because you learn what the company does, you learn why it's bad, why it's good, and that you have this like tribal knowledge that's picked up, right? And so he's basically saying like, okay, obviously you don't know how business works because you're not a business person. You also have just been like working for like, obviously you've been like, working, but you haven't been like me for like 25 years. And then I think third is like, you're just very young, right? And there's just general things. And I think I was like, initially there's some like disagreement, but I think generally he came to like, he kind of just naturally came to his own thinking process where it was like, I guess when he was in that position, obviously he wasn't starting a company, but when he was just studying machine learning, it's not like he knew anything about machine learning either. Like he's just a master's student, and obviously he let it go. But to some degree, he may like regret letting that go because he's like, maybe if I just played around for a few more years or like went all in on it, maybe it could have been different, right? Maybe I could have explored something more, sexier or more interesting. And so I think that was him just being like, you're young, you have some time to mess around.
It's interesting though. The market seems to be speaking in the other direction with its feet. The
Yeah.
average age of founders has declined a lot in the last 2 or 3 years. I think it's indisputable that the youngest people are the ones with the highest AI fluency because they never had periods of their lives when they didn't have it,
Yeah.
basically. And then if product cycles are way shorter, then it would stand to reason that you need more people essentially throwing in new grenades of ideas for the new S curves because the S curves keep getting tighter and tighter. So it may actually be the opposite of the conventional wisdom,
Yeah.
where people like you are coming in with the right level of experience and the right level of freshness to try to shake things up. And had you been at, Apple or Tesla or Broadcom for a quarter of a century, your risk aversion could go up, the narrowness of your thinking and complacency of how things could be done could
Yeah.
go up, and those might actually make the probability of success at architect lower.
Yeah, for sure. I think like, it's obviously we see the rate going down just because when it's about software, right? It's purely about building I have an idea, I want to go build it out. And often young people I feel like are really good at doing that because they're willing to just throw their lives at it. Like, I want to build this, I want to focus in on it. I don't want to look any other way. Like
Yeah.
even when you're older, if you have that idea, you may not have the time or the, even like I said at the beginning, right? I can't even pull these all-nighters anymore. So it's like, you kind of lose the touch, but when you're a kid or like you're young, you can really just go at it and like go crazy. I think, but in chips, it's different, right? It's like you obviously need the idea, but you also need the network. You also need to know these things that are not in a textbook. Like you can't, nobody's going to tell you, there's no textbook that says this is how Apple designs a chip, right? It's all tribal knowledge. It's all very siloed and hidden away. But I think that's where, like you said, right? I think that's where I was, kind of lucky, where in just getting to work for these big companies for, not a huge amount of time, but some amount of time, there was at least enough exposure to see what the problem is and why people, like everyone knows chip design is long, but why is chip design long? That is, maybe not quite clear. Like, why can't NVIDIA just double their engineering team? They have the money, so why can't they double their team and, get the chip out twice as fast, right? There's some scaling law here that is not immediately clear, but it's only clear once you kind of get into a company and you see how they're structured and how they operate. So I think that is, I think that was like the kind of the right amount of exposure to like be in the setting, see the problem, feel the problem. But I think our biggest strength is like not knowing enough about why that is the problem, because then we can start fixing and thinking about like, okay, if we started from nothing, how would we do it today, right? It's like that.
And were you encouraged by things like, I think I recently read that OpenAI did a 9-month tape out for jalapeno or something like that. Is that encouraging to you? What do you make of that in the market dynamics?
Yeah, I think, I mean, obviously it's super impressive feat. Like their team is amazing. Like I think, as I think they say it publicly as well, like, they're very proud of like the team they've built, like I think one of the greatest teams ever, to actually go out and deliver this vision very quickly. Also, I think actually when we started the company, the news was not public that OpenAI was going to make a chip, right? But at least I visibly remember going around saying like, this is going to happen, like this is going to happen, like why would it not happen, right?
Right.
And obviously now it's very clear. Maybe back then it was maybe not as clear, but I think what's also exciting is, there's this, it very clearly is signaling something, right? There's this new, OpenAI is a company that has never built a chip before. And all of a sudden they can go from like, an idea in 9 months, right? To getting that chip back and sent to the fab and everything. And that's exciting because it kind of validates our point where there is certainly a new way to do things. It's not like the old guard of, hire this 100-person team, set this schedule, set this deadline, work with the foundry in this way. It's not like any of that is true anymore. Like all of these things are starting to change. And OpenAI is a great example of a company with a lot of capital and the talent and the freedom to basically play around with how they want to do things. If you're NVIDIA or Broadcom or your other competitors, obviously you have amazing engineers, you have a bunch of capital, but it's very hard to say, this is the new way I want to design. This is a new strategy I want to try, because it is risky to your business, right? It's a multi-billion dollar, hundreds of billions of dollars of product line. You don't want to take risks that maybe are not that worth it, right? But OpenAI, it's like they're starting from nothing, right? It's like we have nothing. We can decide how we want to build this chip. And I think that's why they've been able to do it so quickly, is like just removing the priors and just thinking about the way that they want to do it. I think for us, like that is also a clear signal that like other companies will want this too. Other companies will want their AI transformations. Other companies will want to find new ways of designing. You know, we think of chips as like NVIDIA, Apple, OpenAI, but the market is massive of these like $50 billion companies, $100 billion companies that are like 50, multiple decades old, that are surviving and coasting off of the product lines they have. But there's a risk that they actually will fall behind if they don't fundamentally change the way that they design, right? They may actually die out in the next 10, 20 years. So I think that's what we're excited about, is like working with these chip companies, showing them this new age of design, this new style of designing, this new method of getting things out the door. And then also working with companies that may not have ever even thought that they wanted a chip, but now, or thought that they were going to build it in-house, but suddenly are starting to realize that like a chip is core to my experience that I'm delivering, in the same way that Tesla is, that Tesla's the prime example of that.
The team you've built at Architect is insane. It happened really rapidly with very little funding. Your first funding of 24 million was only announced a couple weeks ago, I think. And so
Yeah.
for a period before that, you probably had sub $5 million in the bank. But you built a team of 10, 15, 20 people where you sort of go down the list, and for each person you say, how the hell did you get that person? How'd
Yeah.
you convince him or her to leave from here and do this and take less money and this and that? I'd love to hear your philosophy on building a great team and leadership, what you think your angle is for talent magnetism, and what some of the most important questions are that you ask prospective hires.
Yeah, I think I'll go down the list. I think the first thing is that it's obviously the mission, right? It's like if you are the people we hire are, the bar is extremely high, and it's kind of extremely high to the point where we reject candidates that we sometimes, we reject candidates that sometimes would pass all of the bars, but we just feel like, they don't bring anything that essentially the rule, I think the rule to go by is the next hire in your company should be better at something, useful to your company than anyone else. So if we are hiring, let's say we want to hire someone on a model training team, we want to, if we have, we have people from Anthropic, XAI, DeepMind, so, we can interview anybody, but even if they have all the boxes, they've worked at great labs, they've done great research, if they don't bring a unique insight or a unique value that is very clearly measurably better than everyone else on the team, then it's a no hire. And I think that is, it requires some discipline. I think it's why
Well, it's an algorithm for maximizing marginal benefit.
Yeah, but it's also a trade-off, right? Because for the first, as you know, for the first 6 months of the company, we were like maybe 5 people, right? 4 people, 5 people.
I remember.
And then you come to the office, it's empty. It's like, why are you not hiring anybody? And then all of a sudden,
now it's literally buzzing.
Yeah,
It's crazy.
And I think it requires some discipline in the sense that as a startup, you are incentivized to get the thing out the door. You need to prove the concept. You need to show to investors that you're making money and you are doing this, right? But I feel like in a field like ours, it's worth it to kind of take the time, find the people that are really amazing, and by keeping the bar high, you also make sure that you want to enforce that as time goes on, right? You can't just afford to let one through because that dilutes everything, right? It's like the average. You get like 90s in a course, and 90, 90, 90. You get a 70, your average is going to dip to like 80, and then it's like hard to bring back up. So I think that's how we think about it. And then in terms of like how we attract these guys, or like, what I say to them, truth is, I'm Adi, my co-founder, is a much better convincer or closer than I am. But I think the general thing that I've picked up from him, honestly, is like, you want ultimately the best people want to feel like they're challenged, and the best people sometimes want to feel like they don't even know how to solve the problem. Like that's why, or that's what drew Audie and I into starting the company as well, right? It's like we don't know how to solve this problem, but it's interesting to us. And so if you go out and look for the people that have all the experience in the roles, maybe they might not be as attracted in a way because that mystery is not there. Maybe if they have some conviction that is possibly even wrong about how things should be done, but they have some conviction, right? Whereas if you hire someone that is obviously directionally very smart, has the kind of general experience you want, has that unique, bright talent that nobody else possesses, and then also maybe does not know enough about the space, that kind of leads to this like interesting moment where one, they don't have the bias, but two, they kind of want to jump in. Like they want to be like, I want to do this. I want to drive an impact. And like those are often the smartest people too. It's like people that don't know how to solve a problem, but want to solve it. We definitely look at companies and try to be very intentional about who we pick. We use headhunters. We're willing to kind of go over like above and beyond in terms of like comp just to get some guy, just because we understand like this is purely like architect success is 50% based on our partnerships and who we work with, how we work with people, the success, but it's also 50% entirely dependent on who we hire. And that is our, main cost really. Like obviously compute is expensive, but really our main like attention and cost and, everything goes into like, how can we bring on the best people and how can we put them in an environment where they make the most progress? Obviously we work very hands-on with them as well. We're technical people by heart. So I also think that most hires like that is they don't want to work in some environment where there's someone up here and then everyone's down here. It's like you want to be with someone who's like beside you, who's also struggling with you, who's like figuring it out, who just happens to be the leader. Not like, oh, this guy's some like delegated leader that I report to. Like nobody likes that, and nobody smart wants to work for someone like that.
When you think about the types of competitors that would emerge in your space, what's the edge that you guys bring?
Yeah, I think a few things. One is like there is obviously AI for chip design is, I wouldn't say new. I would say it's something that many companies are looking at, both internal and external. I think there's kind of a few edges we have. I would say the biggest for us is that there is really, and it comes back to the team, but also a little bit about how the company is set up, is that if you look at the company, it's not just AI scientists. It's also hardware engineers that are working in the company, building blocks, working on projects, working on internal designs, working on things that we may invest more into the future in. And it's really like this almost like fully vertically, I hate this term, but like vertically integrated chip company where it's, you have the world-class ML team. That's like the base that delivers the models, delivers the kind of new technology. Then you have the software team that is developing the tools, the flows, the different agents, the different ways that AI is going to interact with the environment. And then you have one layer on top, which is that hardware team. And by keeping this all in-house, essentially the feedback loop is very tight, right? Your hardware team, if I sell a product to some company, I'm not going to get feedback on it. Maybe I'll get a feedback in a monthly sync, right? But by keeping the entire process in-house, we can really evaluate who's the bottleneck, what's going wrong, what needs to change. And I think that is something that is not really like you can turn around one day and say, hey, I want to start hiring a hardware team in-house or I want to start hiring XYZ people. It's kind of in the DNA of the company. If you look at the general distribution of the team, it's extremely balanced. It's like literally a third ML, a third software, and a third hardware. And that investment has been tuned very carefully to keep the balance. And by keeping this loop in-house, we really have the kind of fastest way of improving our system. I would say, we're one of the newest companies. We've, just come out of stealth with this new funding. But really what enables us to make the progress we do is the way that we think about the team and how we make improvements without relying on external customers to give us feedback, right? That's the biggest way that we kind of keep the loop going.
I'm not a huge fashion connoisseur, but every time we've ever hung out, you've been in very loose fitting, cool, artsy pants. I'd love to know if there's a story around that.
It's more so like something you can just like fall asleep in. That's how I see it. Like, and something where it's like if I wanted to fall asleep, could I fall asleep in these pants? That's the rule. So it could be jeans. Jeans are fine, but they have to be baggy.
So it's like maximum preparation for slumber at any time.
Yeah, it's like if we're like on the Uber back, I'm gonna fall asleep, right? On the at work, if I'm tired, maybe I like go into the conference room and just like dip my head down, right? Like that's the rule, and I think that's a good rule to follow.
I think that's great.
Yeah.
Well, this was an incredibly enlightening conversation as always. I love hearing about Architect, but also your worldviews and how you got here. It's unique, inspiring, and also just getting started, obviously.
Yeah.
Thanks a lot for coming by.
Thank you.
Appreciate it.
Thanks for having me.